go ahead and get started here. Thanks everyone for coming down to my session today and to the summit. Thank our sponsors. They're all out there. If you haven't had a chance to stop and talk to them, do that. And they've got a lot of good information out there and some swag too, so that's always good. And we're getting close to the end, but if you don't have the app yet, download it and find out what's going on next. But let's go ahead and get started with the talk here. I'm going to be talking about unit testing Prism apps, and I'm going to talk about trying to skip a lot of the ceremony of all the setup that we have to do and get right into actually writing tests. And so I want to start talking a little bit about some of the common problems that we have when it comes to testing, especially testing mobile apps. There's really three areas that I think are most common concerns for us. First one being working with APIs, right? So how many times you've got this unit test here, but it needs data from your servers, especially if you're working with the actual service pieces that are getting that data. You've got to interact with APIs. But a lot of times we end up starting apps, we don't have APIs yet, especially if we're on bigger teams. Those APIs might be getting written by another team, so you might know what they're going to look like, but you don't actually have them to call. Plus, it's really hard when you're working with actual APIs in a unit test to control what you're doing and to control the behavior of what you're seeing, making sure you have the right kind of failure conditions, and you requires potentially a lot of live data on the back end that matches your test and stays there to match your test, right? So it's not really a great way to do that. So we're going to talk a little bit about how to work around some of those issues and what we can do to make sure our tests have a consistent API experience and we can test those pieces properly. And I'm leaving, there's three items here. I'm leaving databases off of this because in the mobile world, we don't usually end up touching the databases directly. Usually we're doing something like this, right? Talking to API. API is concerned about the database. We're not, we're just concerned about the API. Other issues that we have are working with dependencies. And how do we get those dependencies? How do we control the behavior of those dependencies in our tests? Making sure that the dependencies were used. So making sure that the API service was called from our repository so that we actually know that we're trying to get the data out of there. All these kinds of things around there. And we really want to keep our tests so that they've got one area of concern, and that is testing the one piece that we're actually trying to go through, not understanding all the other layers and understanding how they should work, but just being able to make them do what the test needs so that you can make sure your piece is doing what it needs to do. And the other major area is dealing with object creation, right? Dropping news in our tests and everything is very similar to dropping a new in our application codes. You're putting that in there, you're creating brittle parts of your code, you're creating, in your normal app, you'd be creating something hard to test, right? But in our tests, we're not really creating something hard to test, we're creating something hard to maintain. And you're looking at, especially going back to the dependencies a minute ago and dealing with news, when you're creating your object you want to test and it's got dependencies, you're now having to create all your dependencies and bring all those pieces in. And if those dependencies have dependencies, it goes on and on. And once you have a situation where you're testing a view model and now you're using another service inside your view model you weren't using before, maybe you added event aggregator or something, and now you've got to go update all this code where you'll have all these news at. So we want to look at how we can get around that and avoid having these issues where constructor changes don't just affect whether a test might succeed or fail, but affects whether we can even compile the test to begin with. We want to get rid of that out of the scenario. So first I want to talk about working with APIs and working without APIs even better. And I use a tool to basically fake the API side of things. So if you look at the HTTP client, where you're going down there and get that, if you look at the constructor on that, usually we're just calling new HTTP client and no parameters in our constructor. We just let it come back out. but it can take in an HTTP message handler. And the HTTP message handler does just what it sounds like. It's got one method on it called send async. And what it does is it accepts a HTTP request coming in and returns an HTTP response message going back out. And that's really the underpinnings of how HTTP client works. It's doing some other things, but for dealing with the messages itself, this is the piece that handles that. And if you create an HTTP client with no constructor by default, it's going to create an HTTP client handler. That's the actual type that implements HTTP message handler that's used for live, actually working with API calls and getting out on the internet and doing those kinds of calls. But because we can supply a custom implementation of it, I use this library, mock HTTP, and it's a really slick library. It is a custom HTTP message handler implementation, and it allows you to process those incoming requests and give back a known response back out of it. It can be configured to expect requests in certain orders. It can be configured to accept wildcards on a URL. You can use strings or URIs to do your matching on it. It has a lot of other capabilities in there. You can match against query strings with some convenience methods on there, and it's really pretty capable. But because it allows you to do that, you can easily swap this out on your calls instead of the standard client handler and let it do all the work for you. So you can create your tests, run your APIs without an API server and get expected behavior coming back from it. So here's a little bit of a sample here of how you can use it. So I've taken out the instantiation of the mock HTTP because a screen size here. But if you take a look up here, see this asterisk at the end of the string here for the URL, and that star tells it to, hey, match anything past this point. So it's going to look for anything coming in an API/user and match anything. And we're just real simple here, telling, hey, respond with a message here. The media type's going to be application JSON, and then we're just going to supply it a string, which is just a JSON string, so that we can control the exact behavior that's going to come back from this API call. The cool thing is you can get a little bit more complex than that. That's a static response. You can do dynamic responses, like the next line is. We're still matching the same way, but our respond command here can also take in the request. So we can actually look at the actual request coming in and then inspect it. So in this case, we're pulling the ID out of the request URL. That star, whatever's after that, we're just grabbing that last segment and saying that's the ID we want to know. And so let's get that and do something with it. In this case, we're just returning a new response message with an OK and giving it some content. It's a little more complex. He makes it simple here, just doing easy things. But this is actually creating a normal response message. So we set our content, give it string content. We have to put the JSON in there, but notice because we're doing this, we have that ID, we can actually shove that back into what's going out. So we can make the data match what's expected on the other side based on what's coming in to our URL or to our request call. And it's just as simple as using a string like this to actually do our tests on it. I'm doing a little sample over here just to show how this works. You can go out and get this from NuGet. And I've already pulled it down over here. Mock HTTP for HTTP client. Just going to add it to our query. Many people have and use LinkPad. It's an amazing tool. It's saved me lots of time when it comes to debugging or just trying out new things. Okay, so I'm just going to create my HTTP mock, and just going to call it, it's just going to be the new mock HTTP message handler. That's the type that he has in there. And so once I have this, I have access to a few different calls in here. And so we had the win, and so we can do the win, and it just, like I said, it can take in a HTTP method, so you can tell it what kind of request you want and a string, or you can just give it the string itself. So if you have gets and puts and posts, you can specify that out here so that you can handle the different calls coming in, or a delete, or whatever else. Any of the standard HTTP methods, you can respond to that there. So we'll just put this in here. We'll go localhost API test. And then once we have that, we can respond. And so we can actually, give it a status code. So you can see there's lots of overrides here. You can even just respond with a bad status code, or whatever you need to do. And we can make this application JSON. And then we just give it some sort of data here. Let's call it tester. All right, and then we want to use it down here. We can just create our HTTP client. If I can type. So it's going to be a new HTTP client. Let's resolve that. And we're going to pass in HTTP mock. And because this is actually a instance of HTTP message handler, we don't have to do anything else with it. And we can just come down here and we can make a call to it. We can do a get async. We'll just copy this down. And we're going to, do what you should never do here. We're just going to get the result from it. And we're going to go to the content. We're going to just read it as a string, not a stream. And we're going to get that result. And then we're just going to dump it. That's a command from LinkPad that lets you dump out the content. So we can see there, we've just made an HTTP call. No actual API server involved anywhere, and we've gotten our results back from it. So we can take that and then use it in the rest of our calls. So we have whatever is going on in our underpinnings, they can get the calls that they need to actually happen and actually process them. Really slick. This is one of the first things I do when I'm setting things up, is get HTTP mock in there into my tests and start creating out the API bits that I need. And you can either define this in your tests as you go, or I usually create a class that gives me default behavior of my API. So the normal things that might need to happen throughout my app, and then I can override those as I go and give it different behavior. Some other things that you can do from it are different matching. So you can, this one here. So we have a when. We also have an expect. And actually, I think I have a slide on the, I talked about it here. Yes, we have expect. Talk about this real quick. And so you can use the expect in replace of the when, and what that does is you can actually have multiple expects, and it will run those in order. So you can expect, this and then this and then this, even the same API call, and make it return different data as your calls come through. So I'm just going to change this to an expect. And I'll just do a couple of these. And get this on the other line here so we can see it. But that's going to be our first expect. And then we'll pull this one down. So we expect 2. And now we're just going to make a few more of these calls. Let's run it a few times so you can see what happens here. And as we run that, we can see we set up the tester first, and we set the 2 expects up. But our data coming back came back in the expects in the order we put them in, and then fell back after we ran out of expected requests, fell back to the original API call that we had defined in there. So It's real nice when you have a default set of actions to be able to go into your test, and at that test level say, configure this expect, because I know I'm going to be doing this. I know I need to get this kind of response. Maybe it's a bad request because you need to test that behavior or other things like that. And you can make sure that it actually gives the right pieces for the part you're testing. So this is how I usually use it in my tests when I'm and in my code, because I need a way to get that the message handler out in my service calls and everything in the service classes. And so I'll usually create something very similar to this, just a message handler factory interface, and just a simple method in there to get out the message handler. And then I'll have implementation. This is pretty much what the standard runtime implementation would be. So it just returns a new HTTP client handler. That's what is used normally for normal interaction and everything. So just as that. And then I would have usually a mock one of these in my test library that uses the mock HTTP underneath it and does all my configuration to set up and has that available to return out. But normal use, you just would put this in your service constructor, let it get injected, and then when you need to use it, just get the method from it and pull it out. Some other cool things you can do with this is that this will also run on the device or on the emulator. So it doesn't just work in your tests, it works anywhere. It's just like you saw, run it in LinkPad, it runs anywhere, it's just .NET code. And the advantage of this is, again, if you're working on an app and two different scenarios, or a few different, but two different, if you don't have the APIs yet, but you need to actually go through the app and use it and make sure things are working the way you expect and everything, you can actually throw this in, set it up, inject it, your mock handler, and get the expected behavior out of your app to be able to run through it. You can do logins, return data to screens, all those kind of things. And the other really nice piece is if you're writing coded UI tests to test your UI behavior, you can also do a build that has the mock handler in there so that your coded UI tests are coming back out with the expected behavior every time. You don't have to worry about, is the server got just the right code? Do I have a login that actually exists on the server? Is all the data there and untouched? All those kinds of things. You can actually have that all expected and let the app be able to run through and do some of those things. It takes a little bit more work to create the layer that handles all those and would do things like a post, adding something to a list that's returned in a GET, but those are all things that can be done. And the sample code I have that I'll be talking about at the end here that you can go look at has some of that stuff implemented in it, so you can kind of see how it works. So the other issue, second issue that we have to deal with is dependencies, working with dependencies, and getting in a situation where we're testing one thing, not all the things, right? So we're testing our view model. We want to test the functionality in the view model, this one command in the view model, and that it's working properly. We don't want to test that the dialog service is working right. We don't really want to test that our repository is working right or that the API layer is working right. We don't want to have to know how all those things work even and what they're supposed to do, because that affects our returned test and everything to make sure that it's actually doing all these other things. We just want to make sure that, hey, when they click the button on here to load the project, that we actually make a call to the project repository's get project method. And probably that we made a call that included the ID of the project we want to load up, those kinds of things, right? And that it happened, or that the data that returns from the repository is what we actually put into our list on our view model, things like that. We want to test that functionality, not how all those underneath pieces work. And so to do that, we look at mocking. And I use a particular library out there, MOQ. You can either say it mock or mock you. I call it mock, so that's what I'll be saying. But I use this library to handle all my mocking. And so what mocking does is allows us, everything's already interfaced. So what some people do is they'll create a mock implementation of their interface, right? So that responds the way they want, and they go through a lot of hoops to make it work consistently, or they end up creating a lot of versions for each different test that they're doing that does the one thing, responds to the one thing the way they want it to, and everything. But I like to not write code anymore than I have to, so I use mock to do this. It has a fluent syntax that allows you to go and basically just say, hey, I want to create a new mock. It's generic. I want to create a new mock of this type. And then you can work with it. You can set up conditions on it. It'll give you an object back out that is of that type. So you can run it through all your things. And then you can come back to it after you've set it up, after you've used it, and ask it if things have worked the way you wanted it to work. Which is really great because it allows you to, in each test that you're doing, be able to create the exact condition you need for that test and work with it. So this is the basic way that you'd set it up. You just create a new mock of whatever your interface is, and it has these setup calls on here. So like I said, it's type safe too with that. So you'll notice there's no strings in here, no magic I'm trying to deal with. All it does when I do a setup is it actually gives me the R coming in here is the type of the mock that it is. So it's an iCart repository. So I have access to the methods in there. I can say, hey, setup, clear all products. That's the actual method call that's in that interface. And if it had parameters in it, I could do things like down here. They have this IT class that is pretty slick. It basically allows you to mock out parameters and other things like that. So in this case, update product takes a cart product object in, and I just say, hey, I want to set up for update product with any cart product coming in. As long as it's the type of the thing coming in is a cart product, that's fine. That's all I need for here. You can also do, there's an it.is with cart product where you can go in there and you can do a condition to make sure it actually gives you a function that provides in the object, in this case a cart product, and you can actually look at it and say, is this what I want? So if you have conditions for different things on here, you can check and make sure this is the time you want to reply to that and everything. So maybe a cart product comes into this with, they want to add 4 items, four quantity on it, but you only have 3 quantity, and you want to be able to give a scenario where the server would come back and say, I don't have that many and everything. So you could have in here, normally it returns successfully, but if I get a cart product that has 4, then it return a failure condition back out of the API or back out of the repository and everything that's on here. The returns methods on here are very flexible as well. So in this case, this is an async method, so it's returning a task, and this is just a static value here. So this returns this task from result new cart product is going to be defined at execution. So when that line executes during the setup, it's done, right? We just gave it an object, and now it has this exact thing will be what's returned every time from it. You can get a little more fancy. In this case here, this returns is actually using a lambda coming in, predicate coming in, and because it's a func, it can take in, it's executed at runtime. So we define it here, but that cart2 array doesn't happen until we're actually responding to it. So until a call comes in to get products, that doesn't get executed. So if you're doing something where you're updating or maintaining some behind the scenes list that you're using with this, it will have changed. So if you're doing like an add and a get on there, your add could put it into the list and your get could return that back out of the list and everything. So lots of different scenarios like that where you can use it. And then the third way is typed for the parameters. So if it takes parameters in, you can actually pass those parameters on into the method that you're going to use there, onto that func. So you can take it in. In this case, it returns the same thing back out. You could use it to look up if it's an ID. You could use it to get an ID out of maybe a list of predefined items that you have in your list that provide certain scenarios. So you know that for this test I need item 5 because it's the one that's going to give me the data conditions that I need and everything. So you can take all those things into account in your test as you're working through it. And that's the setup pieces of how to configure all that. The next thing you can do is actually verify that things happened. So maybe you don't need to actually do anything with an actual method, but you need to know that it got called, right? So if we have an error condition here where we display an alert to the user telling them certain things, then we need to be able to come in here and make sure that happens. And you see here I'm using literals in here, so it's going to match each one of those to the string coming in. Those strings have to be exact. I could use the it is any on there to just say, I don't care as long as this display alert was called. But maybe there's also a display alert that pops up that says save was successful. So this allows you to check that the actual exact condition that you wanted to make sure happens in this process comes back out of it. Everything. This is pretty simple, straightforward. I'm going to show a little demo on this as well. So we come here and add the NuGet. Got it downloaded already. MOQ. Just add it in. Make this font a little bit bigger. And so for this, we actually need to do a little bit more in here. I need an actual program. I'm just going to define an interface. And just going to call it iDemo. And it's going to have a void on it called please work. Okay. All right, so I'm just going to come up here and I'm going to have mock. It's going to equal a new mock of iDemo. And then from right here, we don't have to do anything else on it. We can actually come in and just start calling this. So I'm going to come up here and I'm going to create a demo. So this interface is the type that does all your configuration. The actual mock, this is a mock of iDemo, but it provides a method or property on it called object, which returns you a reference to the underlying mocked object that it's working with. So you can do things with this. So I call that, I come down here and you can see I've got my standard calls here. Here's please work. So I can just call it. If I run it, all the code works. It's happy. That method exists. But I can do some other interesting things with that. So maybe this returns a string. And so if I run this and put the content out, we can see that the null's coming out because we haven't done anything with it yet. Well, there's a couple things you can do. You can do a set up all properties on here, which I got to define the stuff in there. You can set that up though. You can set up defaults to make it return the values. You can also default values for different types. You can also come in here and do a setup. Oh, it's a method, or a method, not a property. Yeah, if it was a property, you would see that. But you can come in here and set up the please work call. You can set up the return just test. So we can see now up my results here a little bit better. So we can see here my result coming back out of it now was test. If I come down here and modify it again, I can maybe add an int to this called ID. And so now I'm going to say, well, I want to take in any int into it, run it. Oh, yeah. 1, there we go. Run it. Still going to run through. Everything looks like normal. But now I can come in here and I can say, well, pass that int in, and we're just going to return the toString of that. So dynamic, we can deal with all those things coming through as we're testing it and do that. The other nice thing is we can come down here and we can do a verify call. So let's use this other one here. So we're going to verify, in this case, we just want to verify that please work is called. So we run that, everything's happy. So this is designed to work with your unit testing, so it's going to throw an exception. So if we come up here and we don't actually call it, you see we have an exception called here. That's a little hard to read. Oh, yeah, it's in the results window. You can see notification was called. And it even tells you it's nice. It says, hey, you said you wanted it. If you didn't give it any parameters, it just assumes you want it to happen. Doesn't care how many times. we can actually come in here and modify this one more time. We can come in here and add a parameter that tells it how often we want it to be called. So we're going to run it, and we see that worst was called once. We call it twice, and then we see that we have the method working and returning, but now it was called 2 times, and we only expect it to be once. And you can specify an exact number of times in there as well. There's a few different methods that you can add in. So that lets you take through, yeah?
Earlier we had the returns with the Lambda. Are you able to do an assert statement to check that you passed in 1?
Yes, well, there's a few different, there's a few different things you can do with it. Yeah, so the question was, can you verify that 1 was entered in? So you can do a few things. One, you could just say, hey, only do this when I get a 1. So if I run this, we got the value. If I run that, I get null. So it's checking it right there. You can also do on this a is, and it's going to give you in the ability to write an expression there. And so if I make this to 2, you see and it's not matched. And then at this point in here, you can do whatever you want to as well. So you can return, other stuff. So we can say, let's make this scoped so we should do a few things. So we're going to just make it, if I is, greater than 1, then we're going to return this value. And then, if I mouse, otherwise we'll just return, 0. Oh, sorry, return 0. So I've passed in 1 to it. I've gotten 0 out. Now if I make this a 2, why did it not match? Do I have other things changed still? Oh, I still have this up here. Yeah. So we're going to take in any int again. So now I got the two out of it. So you can do anything inside that method you need to. It could be, did I get the right things? It's a little harder to do an assert right here. What you could do, you could probably put an assert in there. I don't know if I'd want to do that just because it would make my test fail at the wrong point. But what you could do is you could actually set this up with a flag that you set that says, hey, if it's this, then set the flag that says I got what I expected there. Or you can actually come down here and verify, that either by putting this in, that you got a 1. What am I calling? I'm calling 2 in, aren't I? Yeah, so there it didn't match because I used a 1 instead of a 2, but if I do 2, which is actually being called in, then it's going to pass. So there's lots of different places you can check that. If it's an input parameter, you can check that on the verify. If it's maybe a combination of things or something more complex than just a outright value here, you can do flags or things in there. So pretty capable. So yeah, that's working with mock. You can also do something called setup sequence on it, which lets you do a series of returns. So unfortunately, the series of returns doesn't let you have the expressions coming into it, but let's do some other things. So we can return like 1 here. I'm going to make this a sequence. I'm just going to copy this line, put it in a couple times. 1, 2, 3. So I'm going to call this with a 0. I'm going to call it a few times. And other than my verify failing, you can see that it ran in sequence. I passed in 0 each time, but I said, hey, respond with a a 1, a 2, and a 3. And then after that, it didn't have anything, so I did the default, which would be null on it. But you can set up a series of actions. I know this is going to be called multiple times. I know it needs to change each time that's called in. So, all right, so the next problem is dealing with instantiation. And I kind of had a little bit of a journey going through this. And that was kind of the evolution of, starting with tests that look like this, where I'm using mock, but I'm doing all my setup and my tests. Each test looked like this over and over, to realizing that, I could simplify some things because I had to add another parameter. So I created some methods that did my mock setups for me, gave me an object back that I could work with and everything, so that my test became something more like this, where I'm just calling it defaults to create the things. I'm not having to actually instantiate all my mocks all the time, but I'm still passing them in. And then I realized that really sucks. I just create a method that does a lot of that for me, right? So now I can just go in there and say, hey, create me an editor page and throw this event aggregator on it. This is a particular thing I want to do, but all the rest of the stuff that we had defined here, all these other ones get created by default. So I can just come in here and say, get this, because this is the thing I actually want to test, pass it in, let everything else happen, and then just load it, and great, go check that it got called through there. Problem was, it was still a lot of setup. My test still had to know a little bit more than I wanted them to know, and had some other little issues. And I thought, there's got to be some other way I can do this. And I realized I'm using IOC everywhere. What if I could write a test that was something more like this, where I just say, hey, give me the type I want. I'm testing the order view repository, and get my orders, and hey, validate mock that an iOrder service that it was called, the get orders was called on it once, and everything. So I started working down that route. I created something where my tests started looking a little bit more like this as a whole class. So I had some setup stuff at the top. This part's what we just looked at, blown up on the other screen. I use generics and action to take care of some of the setups. You can see I've got this default setup mock creation that I've created here that returns my data as I need coming out of it. I've got the repository test and constructor here that just sets this up. This is a type we'll talk about in a second, or a class or a method we'll talk about in a second that does all the magic underneath it. But I don't have to create all these mocks anymore. I just tell it, hey, I want a mock like this to exist, and when you create it, I want you to call this method so I can do any setup work I need to do. And then when I go use my test, I just tell it to create one of these, and it looks and sees I need a iOrder service going into that, and it will create the mock, do my setup for me, and let me run through it. And as I was creating this, I wanted something it was a lot of copy pasting from project to project, and I wanted something a little more portable. I started putting it together and created the ease library. This is real basic at the moment. I'm working on improving it and everything. I just released it this last weekend. But it's built on top of InUnit and mock, and it's got support for Unity and dry IOC containers, and also has an extension to have support for some Prism Forms integration. And this is the piece I'm still working on. But it's designed to simplify managing your mock dependencies. And you can check it out. I'll have a link at the end again, too. But basically, it embraces IOC and mocking as the way to do your testing, and allows me to do these kind of setups. So like I said, it's easy to define default behaviors. This is basically how it would work. I would register, call this register mock type, which expects a method that defines a mock of some sort of interface, and that's how it's going to know what it's going to be creating underneath it. And this method, you'll notice this is a function that returns an action coming in here. And the reason this is that I can define this here in my class instantiation, and I can set it to things, but I can change that as I need to go. So here, this is a method that's called each time the test is set up, and I've done this so that it works either in MS test or in unit. The MS test one's not ready yet, but I do that to make it common. So each time each test that's run, the setup calls this and allows you to configure defaults for all your creation methods. And so then if you just called a resolve on it, it would resolve it and run this, this method here to do the setup, and this might be the generic setup. I just need to make sure that this thing works, it returns the right kind of value, or returns a normal set of data out of this method. But the reason this works real good is because it allows you to easily override the behavior on a test itself. So you can go in there, have a test, and on the test, see this is the same field that I was using a second ago, and you can either do a plus equals or an equals if you want to get rid of all the default behavior, or you can just do a plus equals and say, run this as well. So go ahead and do the setup, run what you normally run, and then also run this method here, which is going to come in and do my special setup. So in this case, I'm testing an air condition, so I need to make sure that I don't actually return anything out of this repository call, so that I have the no results condition coming in. And then I just resolve the type like normal, do whatever it is I'm wanting to do here, call my add to cart, execute, and then call my validate mock, which gives me a mock of this type that comes out of the IOC container and lets me verify that the cart was called. Now underneath the scenes, I've written stuff to make sure that each time a test is ran, all the objects in the IOC container are dumped. They all go away, so they get created new each time. You don't have to do the container setup because that's a little bit slow and costly in terms of running lots of tests. If you did it each time, it adds a significant amount of time to your tests running. But because we only actually create the container and register all the types once at the very beginning of the test class creation, each test only has to just throw away whatever the last test had, and then let it build the bits that are needed again fresh. And then the other piece is that I've got, like I said, some Prism pieces in there that simplify doing some things, like doing the on navigation, being able to call that and setting the navigation direction, whether it's a new or a back, so that you can test conditions of when you're going back to a screen. Everything's really hard. This is actually, as far as I can tell, hidden down in the underpinning, so I had to create my own enum to be able to set and pass the right properties underneath it. But it's as simple as this call that's in there, resolve and call on navigated to async. So I can give it a view model type, it's going to resolve the type, it's going to expect it to be bindable base of some sort. Actually, because of the navigation call, it's going to expect it to be a type of navigated to where. And when it gets it, it's going to then call the navigated to with the direction, which is new, and then whatever parameters I've defined here and passed into it, so that I don't have to do any of those steps. I have something that's ready, that all the pages state should be in a state ready for my test to happen, and I can just test it. So in this case, I'm going to call the return of products page, and I also have some convenience methods in there for testing things like that navigations go back async was called at least once. And I also have other navigation ones in there where you can pass in an expression to determine what it was that was done, and determine where, if it was going to the right page or whatever, all those kind of things. You can check the parameters and all that stuff in it. So it really simplifies a lot of that testing. Some resources out there. All this is on GitHub. This presentation is actually on the Xamarin, the Xam Dev Summit GitHub page. So you can take a look at that. You can go to easelibrary.com and find the library, all the information on how to install it. There's your NuGet packages that exist out there for it today. And you can look at the source for the library, see how it's put together. Maybe you don't want to use Ease itself, but you can take a look at that and see how the underpinnings work, and be able to take that and use it in what you're working on and everything. So, and there's a demo there that Prism Forms demo that demos a lot of the functionality that's in it right now for not just Prism Forms, but for all the E's, like all the functionality that it does is in there and everything. So you can take a look at those things and see. So I got any questions that are run through that a little quick because the last guy getting done late, but have plenty of time to take questions if anyone got any. All right, Thank you.